3 years ago, 72 people lost their lives in the UK's worst residential fire since World War II. On the 14th of June, what began as a small kitchen fire spread to the outer walls of Grenfell Tower. These outer walls, its façade, were filled with novel plastic materials designed to increase the energy efficiency, weather resistance and attractiveness of the tower. But plastics can also burn. We all know what happened next. What is perhaps less well known is that this was not the first fire of its kind. Over the last 30 years, there have been over 50 other fires in skyscrapers around the world where the façade has ignited and spread fire rapidly across a building. Plotting these fires chronologically, we immediately notice something. These fires are getting more frequent. A desire for taller, energy-efficient buildings has led to façades being built with new materials providing greater strength-to-weight ratios and better insulating properties. Most of these new materials are plastics, and plastics burn. So, why not ban all combustible materials? Unfortunately, the issue isn't so simple. Plastic-based materials are generally lighter, cheaper, and more insulating than their non-combustible counterparts. Heating and cooling buildings takes a huge amount of energy, accounting for 25% of the world's energy use each year. Plastic insulation offers a practical solution to this problem, and not all buildings with plastic insulation are automatically unsafe. Plastics are also used to protect the façade from severe weather, which is likely to become more of a problem in the future. If combustible materials have to be used in a façade then, the question becomes, how do we know if the façade is safe? How can we measure its flammability? My research tries to answer this question. There is currently no theory or model that can be used to accurately predict a façade's behaviour in fire. However, every year hundreds of fire tests are performed around the world to make sure façades are safe to use on high-rise buildings. Historically, the data from these tests has been locked away and left unconsidered, but we have, for the first time, collected data from hundreds of these tests and combined them into a single database named Kreshnik, after the Slavic god of fire. The trends found by analysing this data inspired a set of complementary fire experiments that we ran last year. While the results of these experiments are still being processed, we believe that by combining them with the data in Kreshnik and using techniques from artificial intelligence, we will finally be able to quantify the relative flammability of different façades and ensure that the walls of future tall buildings are safe.